Objective 2, calculate percent by mass. And as I've noted here, percents are always calculated the same way. A percent is always the part you're interested in divided by the whole thing times 100%. So it doesn't matter if your part and whole are masses or volumes or points for your grade, it's always part over whole. So find the percent by mass of hydrogen, oxygen, and water. The first thing you're going to need to know is what the formula for water is. So hopefully you all remember it's H2O. And then you have to find out how much H2O weighs. So I've got 2 hydrogen, and you look on the periodic table and see that each hydrogen has a mass of 1.01 grams, or AMUs, but we're going with grams here. So it's a total mass of 2.02 grams. And then I've got just 1 oxygen with a mass of 16 grams. So a total mass of 16.00 grams. So then my total mass for water is going to have to be 18.02 grams. So then if I want to know the percent by mass of hydrogen and oxygen, for hydrogen, I go ahead and take the part, 2.02, divide by the whole, 18.02, and take that times 100%. And punch that into my calculator, I get 11.2%. And I rounded it to just 1 decimal place because my hydrogen only had 3 digits, so my final answer can have just 3. For my oxygen, since I already know hydrogen, if you're feeling confident, I could just do 100% minus 11.2, or I could take the 16 and divide by the 18.02 times 100%. And either way I do it, I should end up with, it looks like here, 88.8%. So my second example says a 50-gram sample of water has 5.6 grams of hydrogen. What's the percent of oxygen by mass? Well, one thing, if you remember about the percent ratios, it should be the same percent of oxygen as we calculated up above, but assuming we hadn't just done that problem, I could take the 50 grams minus 5.6, and that would tell me that the other 44.4 grams are oxygen, because the total has to add up to 50. The 2 parts have to make the whole. So now I can take the part I'm interested in, the 44.4, and divide by the whole, which is 50, take it times 100%, and I end up with 88.8%. And again, I expected that because up here we found that the percentage of oxygen in water is 88.8%. And remember, back when we did this chapter, we talked about definite proportions, that as long as it's water, it should be the same percentage. And then number 3 is a little bit different. Explain which has a greater percentage of silver, AgCl or AgNO3. So you're going to have to do a little calculating here. I have to find out how much AgCl weighs. So I get my periodic table, and I see that silver weighs 107.87. And there's only one of them. And I see that Cl weighs 35.45, and there's only one. So I can just add those 2 masses up, and I have 107.87 plus a 35.45. So I have 143.32. And then I go ahead and take the part I'm interested in, which is the 107.87 divided by the 143.32 times 100%. And I come up with a percent mass of 75.3%. And then I do the same process with the Ag NO3. This could have 107.87 because it has just the one silver. It's going to have one nitrogen, with plus one nitrogen at 14.01. Plus now I have 3 oxygen at 16 each. So this is going to have a mass of, my total here, 107.87 plus the 14.01 plus the 3 times 16 is a total of 169.88. Oops. So now when I take the part over the whole, now I have 107.87, and this time I'm dividing by a slightly bigger number, 169.88 times the 100%. And if you're good with fractions or with math in general, you'll realize that because the mass, the whole is bigger, this should give me a smaller percentage. And it does, it gives me 63.5%. So the first one contains a greater percentage of silver, but those are all percent by mass problems you should be able to do.